Don't give me away. It's treat time.
Julian!
Oh,
Hi friends! So I have a confession to make. I'm an addict. Addicted to cheesy poofs. Well, not really cheesy poofs, but as I get older I am horrified to find I'm becoming more and more like Alan Partridge.
I was medically addicted to Toblerone.
All jokes aside, I do find it all too easy to raid the treat cupboard. And while that's normally fine, I'm currently training hard for this marathon in March. So it'd be great to curb that kind of thing. So like a 10-year-old, I need a lock on the treat cupboard. But I need a special kind of lock. A lock that only Nikki can open, but I can't. It also has to look discreet, so a big old keypad, password-enabled thing is out of the question. Also, occasionally, I'll legitimately need access to the cupboard of fun, and in these cases, Nikki shouldn't have to be present to open it for me. A regular lock and key would work, but then Nikki would have the hassle of hiding a key somewhere, and I might find it, or she'd have to carry the key with her all the time, or she'd have to physically give me the key each time, and then I'd have to give it back after I'd copied it, with an impression on a bar of soap, and make my own secret key out of some stuff I find in the prison yard, while having to avoid being looked at funny by Mad Eye Mike. You get the picture, a key's no good. So this all sounds like the perfect excuse to try and make a smartphone app-controlled lock. If I could make one, this would mean that Nikki can open the cupboard as per normal, and could also open it for me, if I've been a good boy, from afar, even if she's miles away. It's internet controlled, so as long as she has a phone with her, she can open the cupboard from anywhere. I've also thought to add a bit of extra deterrent. I'd like to put an optical switch inside the cupboard that triggers when the door is physically opened. If the door is opened, the Doughnut Keeper 2000 will send Nikki an email to say it's been opened. And then I'll get into trouble. Overall, the Doughnut Keeper 2000 is an interesting exercise in software and hardware design. Plus it sounds like a really fun project. Now I've programmed things like Arduinos before, but I've never managed to make something that can be controlled over the internet before, so it's a really fun challenge. I first started with an Arduino, but pretty soon I realised it was too big and too pricey for my purposes. Also, it's not able to connect to the internet on its own. It would require a Wi-Fi or Ethernet shield, and this would make it even bigger and even more expensive. So I went looking for something cheaper and smaller with Wi-Fi built in. I soon found the Wemos D1 Mini. It's like an Arduino in that it's user programmable, but it's really cheap and has Wi-Fi built in. And it can even use the Arduino IDE. That's the software that you use to program Arduinos. So if you're familiar with that, you can program the D1 Mini as well. Now the D1 Mini is pretty amazing. It has the ESP8266 chip on it, and it's actually way more powerful than an Arduino. I think they're very cool, and in fact, it's total overkill for this project. So I found a multi-pack of them on Amazon. Actually, I think these might be D1 Mini clones, so I'm not sure. But they were super cheap, so I ordered them. Now I need a physical way to lock the cupboard. The simplest way of doing this is with a deadbolt and a latch. The deadbolt can be engaged physically to stop the door from being opened. The latch will mean the door can be shut even if the deadbolt is locked, like a regular lock. Now instead of a big old deadbolt, I went with a servo. They're quite powerful, and let's face it, this isn't Fort Knox. I went with these large all-metal MG996R servos, but soon found they were way too beefy to be powered straight off the D1 Mini. I blew a few D1 Minis testing them out, but luckily they're cheap. So next I tried much smaller servos. I went with MG90S mini servos, and these were perfect, like really great, very small and easily powered from the puny D1 Mini. While researching the Doughnut Keeper 2000, I came across the Blynk project. Now jargon alert, Blynk is a hardware-agnostic Internet of Things platform with white-label mobile apps. Simply put, you can use your own homemade DIY phone app and use the app to control devices in your home, or anywhere else for that matter. Now I went to Blynk and had a look at the examples, and it took a little while to get my head around it, but I soon found that there was a basic servo example, and I could alter it to my needs. When you make the app on your phone, you get given a special unique code for that particular app, which will then mean the D1 Mini or any other device you're using will only take orders from your own phone's app, not some random person's app. I can't have any old Tom, Dick or Harry controlling the doughnuts. Eventually I got the servo working with the app. It was very exciting.
Oh my god, it works!
Then for some added functionality, I also added this little optical switch to the D1 Mini. When the cupboard is opened, a paddle will be withdrawn from between the optical switch's emitter and receiver. So once the optical switch has been activated, I'm going to try and get the D1 Mini to send Nikki an email to say that the cupboard has been opened. I've also added a couple of LEDs which I may or may not add to the lock once it's in situ. They will show a green or red light depending on the state of the servo lock, whether it's locked or open. Maybe red for when the lock is open. I'm not sure which way round to make it yet. I'm thinking from the Doughnut's point of view. Lock open, the Doughnut's are in danger. Now I've got the servo moving with the app. I need a physical way to mount this to the cupboard door. I 3D printed a little enclosure for the servo, and it fits really nicely. It's got a full 360-degree safety sweep area, so the servo can safely spin in any direction in case of problems while programming. I also added the optical switch to the enclosure too. Its position can be adjusted later when fitting it. Now I need a latch. I've got quite a few of these left over from doing DIY on the house, but they were all very stiff. So I chopped it about there, and this is what you end up with. Basically a little sheet metal housing, the actual latch itself, and a spring. So I went and 3D printed a little housing, and then the parts can be fitted in. And this cross piece can be moved backwards and forwards to tighten the spring or loosen the spring to make the latch nice and easy to move. And there's just a plate for the back which holds it all together. So this will be mounted inside the frame of the cupboard, and this is mounted on the door. This is the cupboard in its locked position, the servo arm in its locked position. This is open, this is shut. When the cupboard is locked, the cupboard can't pass this point, so it's locked. When the cupboard is open, but it can also shut past the closed servo arm because of the latch, and then it's shut again. And the only way to open the cupboard once it's past the servo arm is to use the app. The cupboard is now free to open. That's the theory. I also thought the standard angle on the latch was a bit too shallow. I want to reduce the strain on the servo arm, the deadbolt as it were, so I increased the latch angle to make it move past the servo arm more easily. So I've 3D printed this little LED holder, and I think I'm going to go with red and blue. Green was kind of too much like go, and really we just want a colour that is bright enough that means things are okay, and I think blue is the way forward for that, and then red will mean cupboard is open. So I've never done this before, but I'm assuming it's going to work. Got a lovely set of wires here that actually came with the optocoupler, and they're 3 joined together. And to keep things neat, I'm going to try and make these LEDs, I'm going to join the negative together and then have one wire to both negatives and then one wire each from the two positive sides, that's the longer sides, and they will go to the respective pins on the Mini. Okay, let's check the wiring. Did I just blow one of them? I think one of them might have just blown. They are on a resistor. Well, let me get the app and see if we can blow the other one. I did see the blue one flash. So, okay, well the red one works, and the blue one works. It must have just been because I just plugged it in. Hooray! Blue means all is good, cupboard's shut. I open the cupboard, there's a little warning light there to say that it's currently unlocked. So now what I need to do is I need to condense all this to fit on this. I'll glue this to the green lock holder that's inside the frame of the cupboard. That should keep all the wiring nicely contained. I've already taken a D1 Mini, one of the other ones that wasn't broken, and instead of having these female headers on, which is great for prototyping, I've put male headers on. So it's important when you do this kind of thing, because there are two sets of legs, 1, 2, and these perf boards have got copper tracks running horizontally here. It's important that if you're going to have a chip mounted like this, that you separate, you cut down the middle, and you make sure the copper tracks don't contact each other across, because then you'd have problems. You'd have a sort of short circuit across the two legs. So what I'm going to do is put that in like that, and then all of these wires here, the equivalent will be soldered into the correct position on this board. Alright, so that's the LED wires all done. I guess I ought to test that. I can't remember if I've already uploaded the sketch to this D1 Mini or not. Okay. Oh, so it's working. Great! Yay! Now I need to do the same with the optical switch. I'm anticipating that when it's all done and in position, this will be hot glued to there, and that way for maintenance or sort of any changes, if I unscrew these bolts, the whole thing comes off. This will be attached to the cupboard wall, and this bit will be, that's what this kind of long bit is for. So that will just kind of slot in like that. Black is negative, red is positive, plus 5 volts, and the white is the signal. Oh good, my holders are finished printing. White is the signal. So the signal one is the only important one, and that goes, by the look of it, to D2. D2 is here. Right, here's the optocoupler. Actually, I don't think it's an optocoupler. I think it's just an optical switch. That goes there. Hopefully we're going to get, there we go. Getting a signal. Sending an email. Sending an email. Sending an email. Great. At the moment the email is my email address, so Nikki doesn't get, that's a bit naughty. I forgot to cut the wires off. That could have been a nasty short circuit. One, snip, snip, snip. And as you can see, it's more of a neat package now. So what's left? The servo. Now it's just the servo left. And that's really easy too. You've got brown, which is negative, 0. Red, which is plus 5 volts. So that goes to the plus 5 rail. And orange is the signal for the servo. And that, I believe, will go to D1. Fingers crossed, it all works. I think that's everything wired up now. The moment of truth. Alright, with a blue light. Nothing on those. Get the app. For some reason these don't work until we do it first. Okay, shut. Open. It flashed up, it wasn't connecting there for a second. Oh, there we go. It's online now. So here we go. Shut. Locked. Open. Danger. Brilliant. So the LEDs work in conjunction with the servo. Now we need to just check that this still works. Yep. And I'll just check to see if we've got an email. Now I just need to fit all the parts of the cupboard. I'm rushing because I need to go for a run before it gets dark. Put these together. And then that should hopefully... Right, it's plugged in. Got to plug it into the mains up here. Blue light, yeah. Ooh, it's obviously locked on the app. Oh, now I've got to use the camera. Damn it, I've got to use the camera to... How am I going to do this then? I'll use my iPad. There we go. Now it's in the locked position. Open, shut. Now this isn't locked into its position yet, so I don't know what's happening. Let me get rid of all these wires here. So, no, it hit the bar. I heard it here. Still too close. I think it's locked. Open. It worked! So, shut, locked, yeah, I can feel it, open cupboard. Woo! Actually, tell you what, I'm going to move the... So here goes. Lock. Awesome. Open. Open. Now I'll have to have a look on the footage to see how it might be on the very lip of the arm, in which case I'll move the latch in a bit. But that's basically project finished. I need to tidy up and do the LED lights beneath the thing. Oh, that sounded better. Now, if it's locked and then I shut the door, automatically locks. Brilliant. Oh, that's brilliant. I've made a modification to the LED wire. I've found some of these pin connectors that you can make yourself. So they will go there. And this is still a little loose. But that's for the power. But I've added one extra wire. I was testing it last night off camera, and for about 5 minutes it wasn't working. And I think my little headers, they're really cheap off AliExpress, I think, and I don't think they're the best quality. And I had to kind of take the D1 Mini on and off a couple of times for it to seat better. And that's quite disappointing. I don't want to lock this and then have no way to open it. So what I've done is I've added an extra wire that goes direct to the servo that comes out of the cabinet, and it'll just I'll just hide the wire under here. And I haven't got the device, but I know you can buy them. The servo testers, you basically plug it in and there's a little dial and you can open something. Well, you'll be able to open this with that device. But I don't have one. I should probably get one, and if I do, I'll give it to Nikki as a emergency way to open it, because that would be really disappointing. I don't want to have to sort of break. If I pull this really hard, either the handle's going to fall off or one of these plastic bits will break, and that would be a shame. So that's my little backup safety thing. And yeah, that's it. I also need to make a little plastic paddle, like a little plastic blade that is sort of here somewhere, that when it's shut, it'll break the beam between the emitter and the receiver, and that'll be the switch that tells the D1 Mini to email Nikki to say that I've broken in. I'm so sad. But it's a really good excuse for a fun project, and I think this might be quite cool, because I went through a stage of having sugar in my tea, and before, like within 3 months, I was having like 4 sugars in a coffee, maybe 5 sugars in a coffee. I mean, they were big coffees, but before you know it, I was getting through a packet of sugar a week, and it's just really bad for you. So I think this would be a really easy way. And Nikki was having to hide the sugar, and I kept finding it by accident. Oh, and then I'd start using it again. So I think this cupboard would be good for stuff like that. Stuff that I probably shouldn't have on hand because I can't be trusted. Is I've moved this about 3 millimeters towards me so that it's much closer to the armature, the arm, the lock, which means that it really makes good, which means the latch makes really good contact with the arm, and before it was kind of just hitting the tip of the arm, which is no good, because it needs to be a bit robust, because I think Nikki or I are going to come along and open this cupboard without thinking, and it's going to have to be strong enough to be sort of yanked fairly hard, and as you can see, that the kind of soft close of the cupboard is enough to overcome the latch, so the latch is lovely and sensitive, so that's nice. If I lock it, locked. I hope you enjoyed the little I'm an idiot. I don't need much of an excuse to make a silly video. Right, that'll do for this first instalment. Don't forget to give the video a thumbs up and please share it if you can. That really helps get the word out. In the next instalment, which should be out in the next 24 hours I hope, I've got to fasten the two parts of the lock more permanently and I'll be finishing up all the loose ends. Also, there'll be a lot more general chit-chat about this project and life in general. Molly might even make an appearance and steal the show as usual. I'll put all the project resources in the description below, including links to the 3D printed parts on Thingiverse and the bad software I wrote to get it all working too, including the extra functions like the LED lights, optical switch and email notifications. Alright, that's it. Thanks for watching. Bye!